Good evening and welcome to this 30-minute revision webinar looking at research methodology. This is the last of our 6 revision webinars in the series, getting you prepared for paper 2, which will take place on Monday, so very best of luck with that. Let's make a start. Quite a lot to get through in this session. We're going to look at starting by revising the sign test, an area that many students are not particular fans of, and look at possible application questions that can come up there. We're then going to look at the difference between experimental designs and experimental methods. We're then going to look at some key components of peer review and see if we can find an easy way to memorise those different key components. And then lastly, we're going to look at the difference between IVs and DVs and make sure that we can write a perfect directional and non-directional hypothesis. If we get time, we'll squeeze in a little bit of ethics as well, because there's lots of ethical questions that could come up in this part of the exam. So to start with, let's look at the sign test, and it's worth noting before we even begin considering how to conduct a sign test why we use one. And we can only use a sign test if we're looking at paired or related data. Now, you may not have come across those terms before, so you might just want to think of it in terms of if we've done a repeated measures experiment or a matched pairs design experiment, then we can use the sign test. Now, let's imagine the following scenario. So Jim, the CEO of TutorU, let's say he's decided to put all of his employees on a weight loss program, okay? And you can see their original starting weights there. I'll quickly put in that none of those are true. I made them all up. And then we need to see actually what their weight is going to be after, a week after they've been on this training program. This is clearly all fictitious. So Jim has lost 10 kilos. His brother Jeff has also lost a kilo. I've unfortunately put on some weight. Michelle stayed the same. You get the idea. So here are the results a week after, let's say. Now, the first step of the sign test is you need to work out the sign itself. So all we need to do is decide, has the score, the weight in kilograms, gone up or down? So that's a really, really easy process. So you'll see that Jim's obviously gone down. Jeff has also gone down. I, unfortunately, have gone up. Michelle has stayed exactly the same. John's gone down. Graham's gone down. Ruth has gone down. Anne's gone down. Haley's gone down. And then Anthony's also gone up. Okay. Now, you could be asked to do that in the exam, and that'd be quite a nice and easy process to do. You might need to complete that part of the table. What's more likely to happen, though, is you'll be given the data already. Okay, so what they've done here, or what I've done here, is I've said that 7 people have lost weight, they went down, 2 people have gained weight, they've gone up, and 1 person remained the same. Now, I've deliberately crossed out the person who remained the same because actually, with the sign test, we're not interested in people that actually didn't change. We're only looking for differences. So on to step 2. Step 2 is where you actually calculate the value of S itself. The reason it's called S is because it's the sign test, quite simply. Okay. Now, you could get a question asking you to do that. For example, you might get the question that says, give the calculated value of S in this study and explain how you arrived at that figure, okay? For up to 3 marks, so quite a lot of marks here. So knowing what to say for this question is quite important. So firstly, you just need to describe, well, how do we get to S in the first place? So what you would say is that the calculated value of S is the score that we get from adding up all of the pluses, in this case there were 7, and all of the minuses, in this case there were 2, and then we just take the number which is the lowest, in this case it's 2, okay? We might also want to sort of acknowledge here that we ignore any non-differences, any nil results. So there was 1 0, but we're going to ignore that, okay? Therefore, very simply, the calculated value of S is 2. Moving on, they might ask you to calculate the value of N, okay? So you might get a question along the lines of what is the value of N and how might you arrive at this figure? And that could be maybe for 2 marks or for 3 marks, okay? Now, in relation to the sign test, N stands really for the total number of participants there are, okay? However, again, we're not interested in anyone who got a 0, so all we need to do is add the other numbers up. So we've got 7 and a 2, which means that our number of participants, excluding the 0 value, in this case is 9. So there were 9 different participants, except for, I think it was Michelle, who remained the same. Okay, so N equals 9, and we've explained how we arrived at that figure. Now, once you've got the value, the calculated value for S, which is 2, and we've got the N value, which is 9, you can then find the critical S value, okay? So we've got a different S value here. This is the critical one, which we're going to compare our calculated one to. Now, in the exam, if they asked you to find a critical value, they would actually have to give you a table that looks like this on the right-hand side of the screen now, because you can't calculate it unless you've been given a critical values table. Now, the way you do that is really, really easy. So let's imagine you got this question. What is the critical value of S for a one-tailed test at 0.05 significance level? Now, you might think there's loads of words in there you don't understand, but simply all we need to do is go up to the 0.05 significance level here. We then just go down the table till we get to 9, because this is the N here. So we go all the way down to 9, which then shows us that we've got a critical value in this case of 1. This is our score here. So now we've worked out 3 different scores. We've got our calculated value of S, we've got our N value, and we've got our critical value of S. all that leaves us left to do is to decide whether these results are significant or not significant. Okay. Now, for the sign test, and you just need to memorize this, the results are significant if the calculated value of S, which in this case is 2, is equal to or less than the critical value for the results to be significant. Okay. Therefore, as our calculated value is 2, that's obviously higher than the critical value of 1, and unfortunately that means these results are not significant. And that's it. So in 5 simple steps, you work out the value of sign first of all, whether the scores have gone up or down, and put pluses and minuses accordingly. You then work out the calculated value of S by taking the lowest score, excluding any nil scores. You then calculate the value of N, which is the total number of scores, again excluding any nil scores. We're not interested in those 0 values. We then find the critical S value using the critical values table, so they'd have to provide you with that. And then lastly, we determine if the results are significant. And to do that, we just answer the question, is our calculated value less than or equal to our critical value? Okay, so those are your 5 key steps. Now let's put that into the context of a question that has come up in, I believe, sample paper 3, okay? So it says here that 20 primary school teachers were sent by their individual head teacher to attend a training course in a classroom behaviour management run by an educational psychologist at a local university. Before the training course and again after the training, the teachers were asked to say how confident they were in managing difficult classroom behaviour. The researchers compared the before and after scores to see how many of the teachers rated their confidence as better, worse or the same as it had been at the start of the course, and the results are shown in table 1. So they've already skipped to step 2. We don't need to do the pluses and minuses. That's been done for us in this particular case. Now, the question that would go with that is give the calculated value of S in this study and explain how you arrived at this figure. Now, we've already done that, so that should be quite straightforward now. So if we think we're ignoring the number of people that got the same score, which in this case is 2 incidentally, that just means the calculated value is 2 because there's only 2 other scores. We've got 16 and 2 and we know it's always the lowest value, so our calculated value would be 2. And then we need to explain how we arrived at that, so we again would say the same thing. The calculated value of S is the score we get from adding up the total number of pluses, which in this case is 16, and the total number of minuses, which in this case is 2, and we take the number which is the lowest, in this case 2. Just to be safe and make sure we do pick up our third mark, we say, however, any non-differences, nil scores, are ignored, okay? You could be asked exactly the same thing. What is the value of N? And explain how you arrive at this figure. And again, we know that in relation to the sign test, N is the total number of scores, ignoring any 0 values, so confidence the same here. In this case, it would be the 16 plus the 2 equals the 18. Okay, so the value of N quite simply is 18, and we've explained how we arrived at that N. They could ask you, what is the critical value of S for a one-tailed test? And I've changed the table here so we could work this out, okay? So we know our calculated value is 2, our N value is 18, so again we would apply exactly the same criteria. We would go up to 0.05 on the table. We're obviously going to scroll all the way down now to 18, which means our critical value in this case of S is 5, okay? So the critical value of S equals 5. We've then got those 3 scores, and in this particular case, again, we know for the sign test the calculated value must be equal to or less than the critical value. In this case, the results are significant because the calculated value is 2, which is lower than our critical value of 5. Therefore, the results are significant at a 0.05 level. And that's it for calculating and working out the sign test. Now, there is one other question that can go with the sign test, and this really is a matter of just memorising this particular answer. They might ask you why statistical tests are used in psychological research. Why do we use them? Okay, and this is a concept you explore a lot more at A2 psychology, at A-level psychology. So the answer is this. Statistical tests are used to work out if the difference we find, say between the 16 and the 2, occurred due to chance, or is it actually due to that training program that's been put on for the teachers? So is there a reason that these 16 people felt better, and is it due to the training course, or is it just really mere chance? We could apply that just to make sure we get the second marks. Therefore, the psychologist was conducting this test to see if the program affected the teacher's confidence levels. Okay. This first bullet point, I would say simply memorise this. For 2 marks, it's a really nice point just to sort of memorise and put in your sort of bank of knowledge, because it's the answer that would use for all of these types of questions if it says, why do we use that statistical test? And that is it for our sign test. Going to move on now. We're going to look at the difference between experimental methods and experimental design. Make sure you know the difference between these 2 key terms really, really clearly, because if you get them mixed up, it can cause real confusion. Okay. So the experimental method over here on the right is a lab field or a natural study. So the method is whether it's a lab field or natural, and the design is whether it's repeated measures, independent groups, or matched pairs. Now, what we're going to supply you with at the end of this webinar is a really, really nice resource, a handout that I used in an activity with my students in my own school, which actually just summarises the different types of design. So independent measures, repeated measures, and matched pairs. And it gives you a strength and a weakness of each one and explains how we actually design that experiment using jelly babies. It's an in-class activity that's really great fun. So we'll supply you with this after the webinar just so you can make sure you know the key strengths and weaknesses for independent, repeated, and matched pairs designs. Okay? Now let's apply that to a question though, because actually there's some particularly tricky questions when it comes to experimental designs that the exam like to try and catch you out on. So let's imagine we get a different scenario now. Apologies, I mean exactly the same scenario. So this is the same one. 20 primary school teachers were sent on by their individual head teacher to attend the training course run by an educational psychologist. I'm going to reread it because we need to know what design was used here. Now, before the training course, and again, the teachers were asked to say how confident they were in managing difficult classroom behaviour. Okay, so we know it's the same group of teachers that actually rated their confidence before and their confidence after the test. Okay, so it's the same group. Now that means in terms of which experimental design it is, it's clearly going to be repeated measures. We've got the same group of participants before and afterwards, okay? Now that would pick us up the 1 mark. What we then need to do is explain why it would be an appropriate design in this particular case. So why is repeated measures appropriate in this particular case? Now, what many students do here is they just give a strength of repeated measures. Let me give you an example. So they would say repeated measures for 1 mark, and then they'd say, this is really good, but because the same group of participants took part in both conditions, a condition before and a condition afterwards. So they go on just to explain what repeated measures is. Okay. Now, if we think about the question itself, the question says, why would it be appropriate? Okay, in this particular case. So this answer isn't actually doing that. It's just really saying what a repeated measures design is and slightly applying it to the question. This would only pick up the 1 mark because we've not done this. Why is it appropriate in this case for this particular experiment? So it's really, really important you actually just sort of use a bit of common sense here, because this question isn't saying what is good about repeated measures or what is bad about it. It's just saying, why did we have to use repeated measures for this particular experiment? Okay, so the answer is actually a very, very sort of straightforward common sense answer, and let me give you the reason here. So you'd say repeated measures because it's important to ask the same people to consider their level of confidence before and after taking part in the training to see if their confidence had changed. Okay. Of course, it's not going to make sense to run this as an independent measures experiment because there's individual differences that might change their level of confidence anyway. So we really need to see the same group of people at the start and after to see the effect it's had. Independent groups will be a complete waste of time here. So really, it is just a simple matter of using common sense in a question like this, and that is what's going to pick you up the 3 marks. So don't try and show off your knowledge about repeated measures here. Just think quite logically in terms of the question, what it's asking you to do. Going to move on now. We're going to look at peer review, a new thing in the AS specification this year. And again, a sort of tricky question. It's just a matter of actually memorising the key components of what peer review is, okay? Now, peer review is a process when someone conducts an experiment. It's where they subject their research to an independent body of other psychologists who work in that area, who will check it in terms of its significance, its validity, and its originality. So if I was to conduct research, I would send it to other psychologists, and they're going to check it to make sure actually my research is valid, it is significant, and it is something original. I've not just copied it from somewhere else. Okay. Now, I've looked for all the different mark schemes, and what we find is that there's actually 5 key points that crop up in all of the different mark schemes, okay? And there's a really, really easy way you can remember the 5 different key letters that go with it, okay? So there's a little mnemonic on the screen here. If you remember this little phrase, peer views are so overrated, it will give you the first letter to 5 key points that you might want to include. Okay. Now, the P stands for published. So the job of the peer review body is to decide, are we actually going to publish this piece of research or not? The second point is the views, is validity. They're actually going to check, are your results valid or invalid? And if they're invalid, they're not going to publish it. Next, they're going to check how appropriate your method was. Did you design your experiment in a way that was appropriate for what you wanted to find out? If it's not appropriate, they would send it back to you and you'd need to redo your experiment. After that, they're going to check if it's significant. If the results aren't significant, they're not going to be interested in publishing them. So if you find out that there's no difference between your 2 groups, then actually we don't want to publish that. It's no point for us. Last but not least, they're going to check, is it original? Is it a new piece of research that you're publishing, or are you just really reusing someone else's ideas? If you're just reusing it, again, they're not going to publish it. So just to sort of recap on those key points, if you remember this phrase, peer reviews are so overrated, we've got those 5 key elements. So is the article going to get published or not? Can we check the validity through peer review? So is it valid or not? We can use it to assess the appropriateness of the procedure and methodology. We can look at if it's significant and is it actually going to sort of add to our understanding of human behaviour. And we're going to check the work's originality. So we've got those 5 key points to remember. A question that you could get, and it's only really going to be a short answer question, you might get briefly explain 1 reason or 2 reasons why it's important for research to undergo a peer review process. We just need to bring in and use our sort of mnemonic there to help us answer this question. So a decent answer to this question would be it's important for research to undergo peer review to ensure that the research findings are valid and that the methodology was appropriate for the investigation. So you'll see I've just picked on 2 of these points. If it was a 4-marker, I would go on to say a couple more. Furthermore, it's to check it's an original piece of research, to check the validity before going forward and publishing that piece of research. So you go. Nice easy way that we can remember the 5 key components of peer review. Moving on. I'd like to explore IVs, DVs and hypotheses with you now, because very often the exam board will ask you to write a hypothesis in the exam. So it's important you know how to structure these really, really correctly, because they're often worth 3 marks, okay? Let's look at a different extract now. So a researcher wanted to investigate whether memory for words presented with pictures was better than memory for words presented without pictures. The researcher used an independent group's design. In condition 1, the participants were given a limited time to learn a list of 20 words. They were then asked to recall the 20 words in any order. In condition 2, participants were given the same time to learn the same 20 words, but this time each word was presented with a picture. For example, the word apple was presented alongside the picture of an apple. They were then asked to recall the 20 words in any order. Now, you could be asked either one of the following questions. You might get asked to state a non-directional or a 2-tailed hypothesis in this experiment for 3 marks. Or you might get asked to state a directional hypothesis for this experiment, a 1-tailed. Okay, so be aware that they can ask you to do either of those 2. Now, the first thing I always strongly recommend you do before even attempting to write this is to work out what your independent variable is and what your dependent variable is, what your IV and your DV is. So if you think about the IV, what are the 2 different conditions? What has the experimenter changed or manipulated in this experiment? Okay, and if we think about it nice and clearly, we can highlight our extract. We've got words presented with pictures, words presented without pictures. Those are the 2 different conditions. What is the experimenter measuring? Now, many students here would go with a simple answer and just say memory. And although this is correct, it's not going to pick you up the marks in a moment. So actually, we need to be much more specific. Memory's not good enough here. We need to say it's the number of words correctly recalled out of 20, because that is operationalized. We can measure that, okay? I can compare one score with another. If I just say memory, I don't know how I'm measuring it. So that's not operationalized, okay? Now, with that in mind, if we wanted to state a directional hypothesis for this experiment, well, what we want to do is make sure we have all of these 3 bullet points in our answer, because each one of them is in reality really worth a mark each. And the way we start that off is really, really simple. If it's directional, we're actually saying we know what way the results are going to go. So what we'd say is there's going to be a significant increase in the number of words correctly recalled. So I'm quoting my DV there. For those participants in the words presented with pictures condition in comparison to the words presented without pictures condition. So what you can straight away see is that actually I've got these 2 bullet points from my IV, this bullet point from my DV. I've included all of the 3 key elements in my answer there. Now, you could get exactly the same question, but the other version of it, state a non-directional hypothesis for this experiment, again worth 3 marks, and it's almost exactly the same. We're literally actually just changing one word. Rather than saying there will be a significant increase, what we're just saying here is that there'll be a significant difference. Because with a non-directional hypothesis, we're not actually sure what way our results are going to go, okay? So we would say there'll be a difference in the number of words correctly recalled out of 20 for those participants in the words presented with pictures condition in comparison to the words presented without. It's literally stayed exactly the same. We've just changed one word, and that has made it a non-directional hypothesis. So just to recap, I've put both of them on the screen there. You can see they're exactly the same worded answer. The only sort of difference is the word difference, funnily enough. So we've got increase if it's directional, or that could be decrease. We just need to be pointing in a direction. And we've got difference if it's non-directional, because we don't know what way our results are going to go. Okay, there we have it. Moving on, we're going to look at finally ethical issues and debriefs, because we've got just enough time to do that, okay? A nice easy way that you can remember the different ethical issues is with the word DRIP with an additional P. So you've got deception, right to withdraw, informed consent, privacy and confidentiality often go together, so that's a nice one to put together, and protection from harm. Now, I'm not going to focus on these themselves today. Actually, there's one in particular I want to talk about. So these are all ethical issues, but debrief is another thing you'll be aware of that you often do after the experiment, and it's that I want to focus on. So let's stick with that previous example we've just used about the participants remembering words with pictures and without pictures. Okay, let's imagine you get the following question, and this is the largest question there has ever been in the research method section, a 6-mark question, so it's quite a big mark answer here. It says here, at the end of the study, the psychologist debriefed each participant. Write a debrief that the psychologist could read out to the participants in condition A, okay, or in condition 1 in this case, okay? Now, what's really important is the mark scheme says that you have to include certain key elements, and if you don't have them, it's going to pull you down really quickly. You need to explain what the aim is. You need to inform them about both conditions. So because they only did one condition, you need to tell them that there was a different condition that they weren't aware of. And it needs to be in what's called verbatim format. Now, if you don't know what that means, it means literally exactly as you're going to say it. Because if we go back and look at the question, it says that the psychologist could read out. So really, you're writing a script here. So it's a bit of a funny question for them to ask you, but you need to write it as if you're actually saying it to the participants. Okay? And here's how we would go about getting our 6 marks. So we might start by thanking them. So thank you for taking part in this study. We're going to go straight into the first required thing. We're going to say the aim of the investigation, that should say, was whether memory for words presented with pictures was better than words presented without pictures. We're then going to tell them that there were 2 conditions. People in condition 1 learned a list of 20 words without pictures, and people in condition 2 learned a list of 20 words with pictures. Now, we haven't got enough to get 6s, so we need to go on and acknowledge some other ethical guidelines here. So what we would also do is tell them that you've actually got the right to withdraw your results from the experiment at any point until the data is published. And should you wish to discuss the findings or any concerns you have about the experiment or even your memory, that they can contact you. They need to know how to contact you. That's then going to get you 6 out of 6. So it's a really easy way to get 6, but just make sure you're writing it exactly as you say it. You state the 2 conditions of the experiment and you state the aim, and that's going to pick you up all of your different marks. There we have it. We are finished for today. So we've covered lots and lots of key elements. There'll be a handout and PowerPoint resources available to download after this webinar this evening, and they'll be sent out first thing tomorrow morning. Any questions you got, feel free to tweet us or drop me an email at joseph@tutor2u.net, and we wish you the very best of luck on Monday. And thank you for watching.